Okay, so in class today we did a little discussion called regression analysis, and so I know that not everybody has access to a graphing calculator at home. So if you do not have a graphing calculator, but you do have access to Desmos, Desmos has it built in a very, very nice way. So I was going to do a quick video about how to do regression analysis on Desmos. So let's take a look at how that works right here. So we're going to go into Desmos right here. And one of the nice things about Desmos is it has built right into it a table feature. So if I put a table in, it's really actually quite nice that it has X1, Y1 ready to go. It's ready what we want. And I'm going to go ahead and put in some numbers. And these are the same numbers I use in the lecture in class. Not that they're perfect numbers or anything special, but it just would then jive with what happened in your notes if you were there to write that down. I'm going to put in those numbers right here. Unlike the graphing calculator that you have to look separately at the graph, this is really kind of nice because it actually makes a graph as you go. Now, I zoomed in a little bit so I could see it here a little bit, but when you look at it, you're like, well, that's kind of a line, but it's certainly nothing that I would say is perfect. But the question is, how good of a line is it? So there is a better way to do this because somebody showed me that once long ago and I cannot remember. So I'm going to show you what I know will work. So I'm going to Control C. I'm going to copy that Y1. And what I'm going to try to do is do like a Y equals MX plus B. But if I said Y equals MX plus B, that would be wrong because it's not perfectly the same. So right on the top of your keyboard, there's a symbol that says tilde. It's shift and just to the left of 1. And so I'm going to do Y tilde M, and I'm going to do X, but I'm going to use this because I want it to borrow these numbers, MX plus B. It just found the equation of best fit. So notice it's telling me the slope of my line would be 2.00826, and my intercept right here is negative 0.4304, which is exactly what we found in class. And notice our correlation coefficient right here is 0.9906. And the nice thing is if we added a few more points, like let's say somebody would get an extra value here at 15, and maybe the curve did something strange and it went down a little bit, you'll notice that when I added that extra value at 15, 20, which was down here somewhere, it wasn't very good or close to the line. It actually made my correlation coefficient get a little bit worse. And as I go, I can add as many points and it will automatically recalculate as I go. Now, obviously you could see that if I plugged in 30, my equation should give me a number something like 50, but imagine it was a terrible one and it gave me something like 30. You'll notice again, it pulled the line down a little bit, but it also made the correlation coefficient get worse because this is not quite as good of a line as what we saw before. So that's a way to do that. So again, to reiterate, let me go ahead and kill this so we can try that one more time. I took Y1 right here. I copied it and pasted it here. Instead of doing equal, I did the tilde, which is up along the top near the numbers. And I did MX1, oops, plus B. I just say, hey, computer, I want MX plus B, and there's my slope, there's my y-intercept, and here's my correlation coefficient, R. And again, we'd like to get a number close to 1. This is sort of close to 1, but not that close. So it's an okay form of a line, but it's certainly not great. I hope that helped. Let me know if you need any more help. All right, have a good day. I'm out.